Today we're going to bring together the last two lessons that we've done, looking at partial fractions and looking at writing top-heavy algebraic fractions as mixed fractions. There's two methods you can use for this. The first one is to do an algebraic long division. The second method is to equate coefficients. We'll look at method 1 to begin with, which is going to be our algebraic long division. So the first thing I'm going to do is I'm going to multiply out the denominator of this fraction so that I can then do my algebraic long division. Okay, so the denominator multiplied out is x squared minus 3x add 2. So I need to make 3x squared here, so I'm going to have a 3. 3 times by x squared is 3x squared. 3 times by negative 3x is negative 9x. And 3 times by positive 2 is positive 6. So I'm going to subtract that off. My x squareds are going to cancel each other out. Minus 3 take off negative 9, so that's going to give me 6x. And then minus 2 take away 6 is minus 8. So first of all, just rewriting this as my mixed fraction. It's going to be 3 kind of whole ones, and then my remainder is going to be 6x minus 8, which I'm going to write over x squared minus 3x add 2, but I'm going to write that back into the factorised form. So I've dealt with the fact that it's top heavy. I now need to write this second part, this fraction part here, as partial fractions. So I know that 6x minus 8 over x minus 1, x minus 2 can be written as something over x minus 1 plus something over x minus 2. I'm then going to multiply my first fraction here by x minus 2 and my second fraction by x minus 1. Okay, so I've done that part there. So now I'm going to let x equal 2. So if I substitute 2 in, I'm going to do 2 times 6, which is 12, take away 8. If I substitute 2 into this first bracket here, I'm going to get 0. So my a's are going to disappear, and then I've got b multiplied by 2 minus 1, which is 1. So 12 take away 8, 4 equals b. And then I'm going to let x equal positive 1. So that's going to be 6 take away 8, a open bracket 1 take away 2, and then my second bracket is going to equal 0, which is what we wanted. So that's minus a and minus 2, so a equals 2. So my final answer I'm going to write up here at the top is going to be my 3 kind of whole ones, then add on negative 2 over x minus 1, add on b, which is 4 over x, x subtract 2. Okay, the second method, it's easiest to use this second method when you know the form that your answer needs to be in. In your exam, most of the time they do show you the form it needs to be in. Using this method on a question where you don't know that form can be a little bit difficult, because where you've got an a at the moment, you might not necessarily know if that should just be a constant or if it should have some x's in and some constants. So it's easier when you know the form that it's going to be in. So I'm going to use a method similar to the method you would have seen a couple of lessons ago. So my aim for the moment is going to be to write the right hand side of the question all over 3x minus 1, x add 1. So to be able to do that, I'm going to need to write the first fraction. I'm going to need to multiply this first fraction by 3x minus 1 and by x plus 1. I'm going to need to multiply the second fraction by x add 1, and I'm going to need to multiply the third fraction by 3x minus 1. So I've written the right hand side here all over a common denominator of 3x minus 1 x add 1. Now that I know my numerators need to be the same as each other, rather than rewriting that out again, I'm just going to get rid of my denominator. Okay, I'm now going to use my substitution method to start working out the values of a, b and c. So I'm going to begin by substituting in x as minus 1. So I'm going to let x equal minus 1 to begin with. So by letting x equal negative 1, I'm getting rid of my a term and I'm getting rid of my b term. So here I've then got 6, add 1, add another 1, and then I've got minus 3, take away 1, which is minus 4. So here on the left hand side I've got 8 equals minus 4c, so then c equals negative 2. The next thing I need to substitute in for x is x equals a third to eliminate the a term and the c term. So working through substituting in x as a third, you may want to pause the video to check that you're happy with this, but we get through to 4 thirds equals 4 thirds of b, so b equals 1. We've now used up all our substitution that we can use for this question, so we're now going to need to do a little bit of equating coefficients for this last thing. So you can decide to equate either your x squared terms, your x's, or your constants. I'm going to just look at my x squared terms for this next part. So on the left hand side I've got 6x squared. From this a part, my x squareds would come from 3x times by x. So I've got a times by 3 lots of x squared. Then the next two terms, I'm not going to get any x squared terms out from those. So just looking here then, I've got 6 lots of x squared on the left hand side. On the right hand side I've got 3a lots of x squared. So then a is going to equal 2. So my final answer then is going to be 2 add on 1 over 3x minus 1 add on negative 2 over x add 1. So it's up to you if you prefer the method we used for the first example, or if you prefer method number 2, completely up to you. I would now like you to have a go at doing this question on your own. You can either choose to use method 1 or you can use method 2. If you would like to use method 2, I've written the form that your answer should look for you to help you use that method 2 if you would like to. Pause this video now and have a go. So starting by looking at method 1, to begin with you need to do your algebraic long division. So I have multiplied out the denominator to get 3x squared add 5x minus 2 and then completed my algebraic long division. Pause this video to check if you made any mistakes in that part. So starting off by writing them over a common denominator and then being able to substitute in x equals minus 2. So when I substitute in x equals minus 2, again pause to check you're working, you should end up with minus 14 and minus 7a. So we then know that a is equal to 2. Then we need to sub in x equals a third. So by substituting in x is a third, we should have ended up with b equals minus 1. So your final answer is here. You can stop this video now and have a go at the exercises, or if you used method 2, I will talk through method 2 now. So to use method 2 for this one then, I'm going to first of all write these n's and p's all over a common denominator of x add 2 and 3x minus 1. You should have ended up with something that looks a little bit like this. Because now my denominators are the same, I can get rid of the denominators on both sides of my equation. I'm now going to substitute in x equals -2 to begin with. That will get rid of my m term and my p term and leave me just with my n's. Working through that, you should have ended up with n equals 2. I'm now going to let x equal 1/3 to work out my p term. Working through that, you should have ended up with p equals -1. Pause if you think you've made any mistakes in that part. We now are going to need to use equating coefficients to be able to work out my m term. I'm going to equate my x squareds, although you could choose to equate your x's or your constants. So from doing that, you should have ended up with m equals 3. Pause again if you need to work through that. So my final answer is 3 add 2 over x, add 2, take away 1 over 3x minus 1. Please now have a go at the exercises from the textbook.